Welcome back, everybody. This is Eric here, and today we're going to be doing another reloading video for you guys. It's going to be cartridge specific. We're going to be talking about reloading 577 450 Martini-Henry boxer ammunition. As many of you know, if you're familiar with movies like Zulu or you're familiar with the rifle in general, Martini-Henry has a very rich service history, a lot of colorful things it was involved in many ways. And also the guns have been a little bit more prevalent really all around the world. They can be shipped just about anywhere as an antique. It's basically sort of like a Peabody action, the falling block, single shot. It is considered a relatively very powerful black powder cartridge. The guns really have been out there in numbers, and they are available on the surplus market. Many of you guys may be familiar with the Nepalese cache that came in out of the Royal Arsenal in Nepal. I got these two rifles that you see from Atlanta Cutlery. Certainly want to take a moment to thank those folks. They've been very, very nice to us in allowing us to come over to the warehouse and select a couple of guns. I am going to say right in the beginning of this video that this video is going to be a little bit on the long side because there's a lot of things that have to be covered properly to reload your own ammunition. It is a black powder cartridge. Black powder cartridge reloading requires a certain amount of discipline to make sure it's done precisely. You don't want to get air in the cartridge, so there's some safety things that we'll go over. Also, making sure that your Martini is safe to shoot, obviously, is going to be paramount. Atlanta Cutlery does not sell their Martinis as shooters. We were lucky enough to be able to go over and select these guns and inspect them and gauge them ourselves to make sure we were getting ones that would be a solid shooter with a good bore and everything like that. So make sure your gun is safe to shoot. If you're not sure how to check, you need to go check a gunsmith, have them look over your gun for you. And also, Ray and I are going to be doing a video in the future on how to check out a Martini to see if it's safe to shoot or not. That's not what this video is about. This video is about, hey, I know my gun's safe to shoot and I want to make some ammo. Now, with that being said, the undertaking that you're about to take on is laborious, expensive, and highly rewarding. Shooting these guns is so much fun, and it's worth the effort to make the ammunition. So, with all that being said, the original video that was put out on this subject was by Jen's Boy 2003. I'll pipe the information down below. His name's Darren, very good friend of mine. Now, he actually lives locally here with me, so I've had an opportunity to go over and talk to him a little bit about case forming for the Martini, as well as a few other things. The bullet mold that we're going to be using today to cast our projectiles is one that was actually cut by Jen's Boy 2003, the YouTuber, and he made it off of an original pulled projectile. He bought a round online, an original round, pulled the projectile, and then cut his cherry specifically to the shape of the original projectile. So for the purposes of today's video, we're going to be producing the closest thing to the original military cartridge that we possibly can for an economical rate. Now, in terms of economics, we'll talk a little bit about price of the components. Now, your dies generally are going to run anywhere from around $100 a set on up to $250 depending on who you buy them from. Lee offers a set of dies that are pretty reasonable. They're high quality, and that's what we're going to be using today. Now, they do use a larger diameter. You're going to have to take the bushing out of your rock chucker press in order to accommodate the larger die size. They are monstrous dies. They're humongous. All right. For brass, you can buy brass from a variety of different sources. I prefer to use the Magtech 24 gauge shot shell holes. They do need to be trimmed, and then they'll need to be annealed and formed. So we're going to go over forming off of 24 gauge shot shell holes as an alternative. You can buy brass from Bertram. You can buy it from a few other places out there. 10X Ammo, I think, gets theirs from either Bertram or Kynoch. I can't remember, but you can get drawn brass that's made from a factory. It's very, very expensive, but it is an option if you're not up to the task of forming the ammo. For the purposes of today's video, we'll be forming the ammo off of the shot shell holes because it is an inexpensive alternative to buying drawn cases. We can make Martini ammo for about $1.35 a shot. versus if we're buying it from companies like Buffalo Arms or 10X or any of the companies that, the custom hand loaders that are making this ammunition for sale. Generally the cost on the ammo is going to be between $6 to $9 per shot. So it's not a cheap undertaking, guys, but you got your brass, your dies, the bullet molds. A lot of the companies like RCBS have kind of gotten off of their butts and finally cut specific bullet molds just for the Martini-Henry. The nominal bullet diameter that you're going to need to be working with is around a 468. Now you'll need to slug each individual rifle to see exactly the diameter bullet that you want to use. Now luckily both of these long lever rifles, these are Mark IV, first grade long levers, okay, late production Martini-Henrys, they both slug right at 467. So 468 bullet like we have ready to drop here is going to work perfectly. The original military cartridge used a 480 grain projectile, so very heavy projectile. Moving gingerly around 1,400 feet per second. The original cartridge was launched with 85 grains of what would be considered 1F black powder. Now we are going to be using 1F black powder today. We've got some Swiss black, very high quality Swiss powder we're going to be using. We're going to be loading 1F, and then we're probably going to go ahead and step up to some 1.5F. Now you can load the cartridge with 2F powder, although I would not recommend it because the recoil impulse is snappy, brisk, and you're not really gaining any velocity with using the faster powder, and all you're going to do is just produce more recoil. The original cartridge calls for a slower 1F powder, so that's what we're going to use. We are trying to replicate the original cartridge as closely as we can. So we discussed bullets, brass. Generally, that's about it. They're fairly straightforward to load for once you understand the mechanism. They are picky on trim length, so make sure you're trimming your brass to a very consistent length. Now, unfortunately, there's not a lot of case trimmers out there that will support this humongous piece of brass here. And for those of you that don't know, I mean, this is a very large cartridge. Everything about it is pretty big, okay? So there's not really a lot of case trimmers that are going to hold a shot shell. So we have a micro lathe that we're going to use to cut down the brass. Now you can also use your full-size lathe if you're up on setting it up and indexing it and then cutting it. It's laborious, it's going to take some time, but what we're going to do is we have arranged this video into sections to where if you check the description box below, you can skip to the different sections. So we've already talked about what you're going to need. We've talked a little bit about the guns. So what we'll do is we're going to go ahead and start forming some cases. That's going to be probably just the first thing we're going to go to, and as we go through each process, I'll document it for you guys so you can see exactly what we're going to be working with. Stay tuned because you'll find that this is actually a pretty fun process. Even if you don't intend on making this ammo or intend on shooting the guns, if you're a hand loader, this is something that I feel some of you guys will get a kick out of, even if it's something you don't intend on doing. Now, with that being said, we're going to get started. All right, it's going to take a while, but let's get to it. All right, guys, so moving along, first thing first, we have to trim our 24 gauge shot shell holes down to 2.29 inches. That can be accomplished in a variety of ways, but for the purposes of this video, we're going to be using a TIG micro lathe. This particular lathe is set up for running relatively small items, which makes it perfect for this purpose. I'm just going to move this carriage out of the way right here. This is a centering point that's designed to keep this thing from flexing while it's spinning, so we get a nice, consistent, true cut. Just going to go ahead and install it here. And some of you may not have access to a lathe. You're going to find that trimming these 24 gauge holes is going to be a very difficult task if you do not have some form of a lathe. What I've done is I've marked the base of the lathe here with a Sharpie to show me where my carriage needs to stop. So I'm going to go ahead and start the lathe, and we're going to be trimming off a pretty good bit of material, maybe about a little over 1/8 of an inch, actually 1/4 inch. All right, I'm going to go ahead and trim this up. That's it. Nice clean cut, nice square cut. All right. This has to be performed for every single piece of brass. Okay. Now what will need to happen later on, once we've formed the neck for our 577-450, see, we'll be necking this down to 45 caliber. So we're going to make quite a stretch on this thing. And once we do, we'll have to change the dimensions here to accommodate for the smaller neck. So we'll go ahead and make that change here in a moment, but first we're going to have to anneal and start forming some cases. So let's go ahead and get after it. Pretty simple. What we need to do at this point, before we can start any type of case conversion or necking down, we've got to anneal them first. And what annealing is going to do is it's going to kind of relieve the metal. The brass is kind of going to go at a molecular level. It's going to kind of calm it down. All the molecules are going to kind of calm down and spread out and chill out for a minute. And we want to do that so this will be easier to form. If I were to try to squeeze this piece of brass up into that die right now without annealing it first, it would probably just crack or split or form some type of a run that would just split all the way down the side of the case, and that's not what we want. We want this thing to remain solid, so basically what we've got set up here is a little DeWalt 12 volt drill with a spark plug socket adapter here, and we've got a little 3/8 adapter for the drill so we can spin it. All right, and I've got it set real slow, and all we want to do is this depth ends up being just right for where we want our shoulder to form. So we're just going to take our MAP gas torch, we're going to heat it up. Now what we're looking for is it's going to turn kind of a brown to a little bit of a brownish color to kind of a reddish, little bit of orange in there, and then it'll start to turn almost kind of a purple color. But then as brass gets hot, it'll turn cherry red and almost kind of a white. We don't want it quite that hot. Hopefully I can demonstrate here for you. All right, we're going to dunk them over in the water when they're done. I'm just going to go ahead and anneal a few of these for you. A little hot, but it'd be fine. I'd rather it get too soft than not soft enough, because the rework hardening process, as I drive this casing up into the die, it's gonna harden the brass again, which is fine. We want to rework harden it under our circumstances here. About right. Let the color be your guide. That's what you're looking at. It's a very specific color. A little bit of purple beginning to develop near the end. The heat sink is going to draw that down towards the socket like it is right now. A little bit of white near the end, which is fine, and dunk it. All right, so we're going to dry these off, and we're going to move over to the press and begin some forming. All right guys, this is the part of the operation where you're going to pull your hair out if you're not careful. The annealing softened the brass where we wanted it. We've got to bump this brass up inside the die carefully to begin to form our neck in intermediate steps. In those intermediate steps, we're going to rework harden the brass over again. All right, so I'm going to try to demonstrate that for you. Guys, if you haven't done it already, whether you're doing this operation or not, pick yourself up a tin of Imperial sizing wax. It's excellent for case forming. Go ahead and put a reasonably decent coat of Imperial sizing wax on the outside of the brass, and a little bit on the inside too, just for good measure. And we're going to go ahead and begin kissing this thing up inside the die bit by bit. Now I've got the die backed out. When the die screws in all the way down to where the lock ring contacts the press, it's touching the shell holder. The base of the die will be contacting the shell holder just like it's supposed to. But we don't want to start out there. We're not just going to ram this thing up in there. So let's go ahead and just begin, give the die a couple of turns. and then go ahead and start kissing it in there. All right. All right, we just formed our initial bump. Now let's go ahead and pull it out and inspect it. All right, so what we did is we began bumping that shoulder. We began forming the shoulder. Now at this point what I do is I inspect it and make sure that we're not beginning to get any wrinkles. Now what will happen is if the mouth of this case begins to wrinkle a little bit, what you'll want to do is just grab your chamfering tool and just give it a slight little buzz on the inside with your chamfer tool. I've got a 50 BMG one laying around here somewhere. And that will hopefully prevent that wrinkle from continuing in the case. So let's go ahead and keep bumping it on up in there. And we're going to form our shoulder here. That's actually going up in there nice and easy. So that tells me that our annealing did its job. So again, we've bumped down and formed that neck. Okay? That's exactly what we're trying to do. We formed our shoulder, rather. All right, we're going to continue along. Okay. Okay, very good. We formed our shoulder intermediately, and we've began to form a little bit of what's going to be our neck. All right, let's go ahead and bump it in a little more. Now, by going in and out of the die, we're actually work hardening the brass again, mind you. Some folks will say that a second annealing is necessary. It really just depends on how many steps you end up using to actually size the case. So what I'm going to do, I'm going to go ahead and bump this thing up as far as it'll go, and then we'll screw the die in the rest of the way and we'll inspect our work. So here we go. Okay, that wasn't so bad. If you begin to feel some odd resistance, then it's probably an indicator that you didn't anneal good enough. So that formed our initial neck. Now I'm going to inspect at this point for lube dents. We don't have any lube dents, so I'm going to go ahead and apply just a little bit more lubricant. Okay, we're going to screw the die in all the way now. And I'll tell you what, since I think we're good at this point, I'm going to go ahead and send her home. Okay, that was a stretch. Let's hope we didn't split anything. All right. No lube dents. No splits. The mouth didn't cave in. All right, so at this point we have pretty much intermediately what is a 577-450 case that we can load, but we're not quite there yet. What we're going to need to do from here is we're going to have to check our trim length, make sure, because what happens is when you size brass down like that, especially when you're necking down, you are squeezing the brass, and where the brass is going to squeeze is forward. Brass always flows forward. So what happens is this case probably stretched a bit from our original 2.29 inch measurement. So that caliper is right here. Let's go ahead and measure him. Now we started out at 2.29 inches. After we formed it, let's see if we stretched it. Okay. We are at 2.32 inches. So we got quite a bit of stretching there. This particular case probably would not chamber inside of most of the martinis that we have available to us here. So that means that we'll have to run back over to the TEG micro lathe and we'll trim off our additional bit of distance we need there. And then we're going to bump it one more time through the die to make sure that shoulder is set back all the way. And then we're going to function test them in our martini. So that process that I just did, you're going to repeat for every single one of these cases. So I'll tell you what, I'll move through the motions here. We're going to go kind of quick, and I'll go ahead and size a couple more of them for you. All right, guys, here's a piece of brass that we got a little bit overzealous with either our TEG micro lathe when we trimmed it, or when we were drying it off, we might have tumbled it around a little bit too much, and you can see where there's some slight indentations here on the mouth. What we're going to do is go ahead and size one of these and see if that's going to be of any consequence to us. So same process, and this is one that I'm hoping will actually wrinkle so I can show you what it looks like when you ruin a case. All right, so We've already got some preconceived wrinkles there that could give us issues. Let's see if it's going to be of any consequence. We're going to go ahead and bump our shoulder. All right, we'll see what we end up with. Look at that. Formed it right out. So let's see if we're in luck here if we don't have a ruined case. So let's go ahead and start forming our shoulder. And you can feel it. It's really weird. You get a feel for what's being done, and that's hard to show on the video. Okay. All right, there's our shoulder beginning to form. Looks like we may be in luck. All right, I am going to have to stand up here. I'm going to have to put some of my body weight down on this. It's quite a squeeze. Okay, that felt good. Our annealing is perfect. We have no oil dents in place, which is exactly what we want to see. Now guys, what I'm referring to when I'm talking about an oil dent, I'm talking about little bitty imperfections and dents that occur in the body of the case from having too much lubricant on the case. Now it's not a big deal if you get oil dents. Don't panic. Fire form it out and your gun will never know the difference. All right, so go ahead and chase our die in. Now remember, we're not quite so worried about this die being seated nice and hard because we're going to trim and then bump the shoulder again. So let's go ahead and finish her up. Yeah. All right. All right, so there is a case that we started out with a nasty wrinkle on the mouth, but because of our expertly done annealing, getting our annealing just right, getting the softness of that brass and ready to work, we didn't lose a case. So there's two successful pieces of brass that are ready to be finished trimmed and the shoulder bumped. Let's go ahead and head back over to our lathe and go ahead and make our trim, and we'll go ahead and bump it. Let's do it. All right guys, so back over to the TIG micro lathe. This doesn't have to take a long time, but basically all we're doing is kissing the end of the brass again with the cherry. I've got the base of the lathe marked with our 2.29 inch measurement, and all we're doing is removing that little bit of extra material off the front that we created when we made our big stretch, because you know that is quite a bit of a necking down operation there. So I'm going to go ahead and proceed to do that now, get all these trimmed up, and then we're going to run them through the die one more time to bump them up. Going to be taking off a very small amount of material. That's it. Just that little bit. We probably took off about 15 thousandths, if that. All right, so that went off. I'm going to go ahead and do one more for you while we have this set up. And then, of course, we'll chamfer and deburr where we made our new cut again. So I hope that you guys are seeing the amount of effort that goes into shooting a Martini. It's quite a bit of work and effort goes into it. All right, so one more just for good measure here. Hopefully you guys can see the amount of effort that's required to shoot a Martini. It's not really that big of a deal. It's just one of those things that's a little bit of extra work. That's it. So that's literally all we're doing in this process. So there's trimming our brass, removing our little bit of stretch that we got there. That's looking good. We just need to do a few more things and we'll be ready. Let's get after it. All right guys, well we got our final trim down to 2.29 inches. You may find that for your particular rifle that the trim length might need to be just a little bit shorter. That's fine. It is a rimmed cartridge, so you don't really have to worry quite so much about trim length. You might run into some issues with having enough neck space for all of your components to go in, which you'll see in a moment. But other than that, don't be afraid to chase it. You know, another 30 thou if you need to, maybe 10 to 15 thou. Don't panic if you have to remove a little bit more metal and bump the shoulder back in order to get the round of chamber reliably in your gun. I mean, remember guys, these firearms are old. They've been around a while. Some of them have been shot a lot. We're going to go ahead and all we're going to do here is just run it one more time through the die. We've got the die seated this time with a die wrench, so it's really, really tight. and we've got our shell holder set up to cam over ever so slightly, like that. You want it to bump slightly to make sure that that cartridge is going all the way up inside of the die. If you don't have that shoulder pushed back as far as it can possibly go, you could have chambering issues in various guns. Especially if you're like Chad and I, we've got numerous Martini-Henrys. So we want to make sure that this round is going to fire in any Martini I put it in, whether it's a short lever made in the 1870s or one of the long levers that's made later. Some of them do have some minor chamber differences in the dimensions. So let's go ahead and bump a few of these. Real basic, guys. And then what I'm going to do is just kind of inspect. Yep. Yeah, that shoulder did get bumped back just a bit. So that's why we go through that extra step. We're going to go ahead and bump them. And at this point, we're not really worried about lubricant. We don't have to lube these. This is also kind of the final work hardening process. So what I'm going to do is go ahead and bump all of these. Our last little bit of work hardening. And then what we'll do is measure them again, make sure everything's good, which I don't expect any problems. Now, after this, what we're going to do, I'm going to take all this brass that we just formed, and we're going to test it in both of the rifles, make sure it drops in and out nice and clean. I'm going to go ahead and do that now. Very simple. All right, guys, we're going to undergo the final quality control phase of this brass to make sure it's going to chamber in our guns here before we prime it. Obviously, we don't want to load and prime this ammunition until it's ready. And I just like to confirm that they're going to drop in nice and smooth. And one of the issues that I've found with these Martinis is that, one, if the shoulder is not set back just right, you'll have chambering issues, which don't ask me how I know. I've had that issue happen to me before. And what will happen is the brass will sort of refuse to chamber readily like it needs to. And what will happen is the breech block, as it closes, will drag the rear of the primer, and let's say you're in a hurry, you're doing a speed run or something like that, you're trying to load it fast, that breech block could catch that primer just right, and the gun can fire with the breech only being closed about halfway. I've had it happen to me a couple of times. No negative result occurred, both to the gun or me as the firer, but that's why I've always just made it a point to make sure that all of my brass fits properly, and I like to confirm that. Now, the chamber on my gun is a little bit tighter than Chad's gun over there. So if it'll chamber in my rifle and eject readily without any, forcing it or anything like that, then we know we're in good shape. But we are going to confirm a couple of them in Chad's rifle just to be sure. Certainly not bad there. All right, so we've moved on to Chad's Martini, and we're just going to test a couple of them in his as well. Just to make sure everything's good. We've got a nice amount of space there. I don't think we're going to run into any problems. So go ahead and test your brass once you're at this point. Oh yeah, plenty of space. We have probably about 3 or 4 thousandths on the back of it once the breech is closed, which is fine. Any more than that, I would consider headspace as being an issue, but as long as you're not having a huge gap, then you're fine. That's looking good. All right, guys, so we're going to go ahead and prime these up. I think we're ready to move on with this project here. All right, guys, so moving along to prime, we've got our shell holder set up in the RCBS press-mounted priming tool. All right, we've got these strips loaded with Winchester large pistol primers. That's what this particular lot of brass calls for. I know a lot of you will be tempted to run large rifle, but it's not necessary. Just run the large pistol because they set in there real nice, about 1/1000th below flush, which is what you want, especially when those breech blocks are somewhat notorious for dragging the primers if the seating depth is not right and your shoulder is not set back where you want it. In this case, everything looks nice. I'm going to go through and prime all these, and we'll be ready to start doing the fun part, which is load the ammo. All right, guys, well, we've casted up our projectiles. The next step in the process is going to be to lube them up a bit here. We're going to run them through our Lube-O-Matic. It's got a 468 sizer in it, and basically the way this operates is the bullet gets placed into the die, press it down inside, it sizes it, This vessel here is pressurized with just a manual crank here, and it just forces the lubricant down through the die. I got a little overzealous there, but that's okay. We got a little bit of lube that flowed up around the projectile, but that's fine. And that sizes it out at 468. And a couple of things it's going to accomplish to size the projectiles versus running them as sized, or as cast, I should say. Sizing them is going to give you a little bit more consistent base. It's going to prevent wrinkling of the neck when you seat the projectile. You know, your other expanding die is going to open up the neck to accept the projectile, but sometimes you'll get them casting slightly out of round or anything like that. So what this does is it makes sure that each projectile is exactly the same in terms of the diameter and the base of it being nice and consistent. So literally just a matter of setting the projectile in there into the die, give it about a half a crank, check it. Okay, we got lubricant, filled out the grooves completely. It sized it. That looks good. Pretty straightforward process, guys. This is just kind of par for the course for casting. If you're casting rifle projectiles, there's a pretty strong chance that you're going to be running some type of bullet sizing machine. This particular one obviously being a Lube-O-Matic, which is a very good machine. I've ran some of the Lyman products before. They all have their ups and downs depending on how you look at it. Also, some of you might live in colder climates. They do offer a heater for this unit that goes on the bottom and allows this casting here to stay relatively warm to help the flow of the lubricant through the base of the machine so that this thing doesn't get too hard to crank. Because if it's cold, you're in a cold climate and you're really having to crank on this thing hard, it can not really damage the press itself, but you don't want to put undue wear and tear on the press itself. So there's your sizing process. We've got our bullets casted, we've got them sized, we've got some of our brass ready to go. We're going to go ahead and start dropping powder, and we're going to proceed to get some ammo loaded up here. Before we go on to charge our cases with black powder, we're going to go through and expand the mouth of each case to make sure it'll accept the new bullet. Follow the directions that are in your die set for doing such. It can depend on different brands of die sets. These are Lee dies. Some may be different, so we're just going to let you guys be at your own accord on that. But go ahead and expand. All right, and you don't want the end of the case to look like some ugly blunderbuss at the end. You want it to expand it and flare it out just enough to where your projectile will kind of sit in there just like that. Okay, that's going to be just fine. That's just the right amount of expansion to get what we're desiring there. So we're going to go ahead and proceed to drop our powder, and we can go ahead and move on with the process. Guys, it's downhill from here. This is very easy. We'll go through and get these expanded and then move on. All right, guys, so like we mentioned in the intro, we're going to be running some of the Swiss black powder here. It's 1F. Very high quality black powder. We are running real black. Black powder is measured by volume, but the volume corresponds with a given weight. Now, there's been a lot of controversy over the years where people go, well, weigh it. Some people go, well, don't weigh it. Weigh it by, volume. Well, I've come to the conclusion that volume is a pretty good indicator, and what I'm going by is the military loading. The military loading calls, if you look at a cross-section of a Martini-Henry case that's done by military drawing or whatever, you'll see that the powder fills up to just about the base of the shoulder, if not further. What we're going to do is I did measure out 85 grains of black powder. 85 grains fills up a Martini-Henry case to this amount where I've cut this off. So what I've decided to do is make myself a powder measure out of a Martini-Henry case. So what I'm going to do is use this as my volumetric powder measure. So what we'll do is we'll just take some 1F, and I've got myself a little tray here to take care of some of the spillages that I'm sure I'm going to get. And we'll just grab ourselves some black powder here, and it's going to kind of spill over. That's fine. All right, so let it spill over a bit. That's why I've got my tray here to catch all my powder, so we can just pour it back in the container when we're done. Grab my little card here. Skim it off, and I've got 85 grains by volume of the powder that I need. Go ahead and grab a piece of brass, Run with your funnel. Go ahead and fill it up. Okay. Got 85 grains of black powder in there, and we're ready to go ahead and proceed to the next step. All right, guys, we are going to have to make one minor modification to the original military loading because the military loading, once they switched to drawn brass, the brass was of a thickness that was considerably thicker than what this more thinly drawn 24 gauge shot shell hole is. So that means that if I put 85 grains of powder in this cartridge right here, it's probably not going to fill it up to the level that the military cartridge was filled up to. Now, the military cartridge uses a series of wax paper discs and a small plug of wax, which I'm going to show you how we're going to make in a moment. Chad came up with a pretty ingenious way of cutting these things to just the right diameter. He took a 4570 case and he drilled and tapped the back of it, all right, for a screw to run in the end of it. And then what he did is he hooked it up to a drill motor, and he can spin it and cut these discs after chamfering and deburring and sharpening up that 4570 case, and allows us to cut our perfectly formed discs. Now, these are just cut out of a little juice carton, all right? It's kind of a cardboard substance with a kind of waxy impregnated coating in it, and they're 30 thousandths of an inch thick. Okay, so we're going to need 2 of these per cartridge, and we're going to need our tift of wax, which we'll move to in a moment. But what I'm going to do is we're going to run just a little tift of polyfill here to fill in the additional volume that the case just is not able to take with the powder. So we're going to grab and just push a little bit of this down in here. And all this is to take up volume. This wasn't in the original military load, but we have to make sure we get every little bit of air out of the cartridge. You cannot have an air pocket in there or you'll get an explosion, and it's not the good kind of explosion. It can create a pretty nasty spike in pressure. So we drop our polyfill on there, and what that polyfill did was fill up the volume where the shoulder starts to form, because our powder is only up to about right here, just above. We got about maybe 1/8 of an inch worth of air that we have to fill up, because what's going to happen is this cardboard wadding is going to get dropped on top. So we'll just pick that up like that, push him home with our little ink pen here, all right? And that's going to settle in nice and clean right down there in the bottom of the neck, right where we want it. Right where my fingernail is where that cardboard is sitting. So we're going to go over here and pick us up a couple of bits of wax here in just a moment. But I'm going to go ahead and set up the rest of these. You're going to repeat that process. Now, you can weigh the polyfill if you want. I find that it's convenient to just kind of roll out a piece that's about the size of a cotton ball. You can use a cotton ball if you want. I find that polyfill is cheaper. It's basically the type of material. It's polyester, and it's what they put inside of like stuffed animals and toys and cheap pillows and stuff like that. So again, take our polyfill, stuff it in there to take up the airspace in the case. Stuff it in nice and tight, because we do not want any bit of air in that thing. All right, run that in there, grab one disc. That one's even got a picture of an orange on it. Look at that. It's going to make it shoot even better. And then send her home. So let's go ahead and top that off with a plug of wax followed by another disc. We'll go ahead and move on to that right now. All right, guys, well, I swear we are getting close to seating this bullet, but not quite yet. Here we've got a silicone bake tray. Now, if you guys are hand loaders, you've got to have some of these silicone bake trays laying around. They are very, very handy for a variety of different tasks. In this case, I've taken pure beeswax and I've poured a thin layer in the bottom of this silicone bake tray. We've already got our polyfill, our charge, and our first cardboard disc in the bottom. So I've got the charge here. It's not going to come out because I've got pressure on it. We're just going to take our brass and use it to cut our little disc here. So just push in. All right. Hopefully that wasn't too thick of a disc. That was a relatively thick disc there near the edge. I may have to, probably what I'm going to do on that, since that one was a little bit thicker than I wanted to see, we're going to probably go ahead and, you know what, I'm just going to stuff a disc on it anyway, just to show you guys. So we're going to start that with our fingers. Set this here and we're just going to push her home. If you get a plug of wax that's a little thicker than you'd like to see, don't panic. It will compress. Not that big of a deal. All right, so that leaves approximately about that much space for our bullet to seat. You notice that this bullet, relatively long, that's going to compress quite nicely. Even with that thicker block of wax in there, that's not going to be a big deal. So we're going to segregate that one, put it to the side. And again, I'm going to go a little bit further towards the middle. For this one, I'm going to go a little bit closer towards the middle. And let's just see if we get the proper disc size that we want. Okay. So give it a little spin. All right. That plug of wax is about a little over 1/8 of an inch thick, which is exactly what we want. So again, we're going to take our other cardboard disc, push it on top, and that's replicating the original military loading quite nicely. And then we're going to push it home with just an ink pen here. And that's going to smush down real nice. Once we seat the projectile, that's the only step left to do, seat and crimp. And this gun is ready to shoot this cartridge and we're good to go. So I'm going to go ahead and do one more for you here. So again, cardboard disc, plug of wax, okay, another cardboard disc. So that's a total of 60 thousandths worth of space that's being taken up just by the cardboard disc. That's going to seat down nice and firm, and hopefully we're going to have enough neck length to get our bullet to seat like we want. What that wax is going to do is it's going to help prevent too much buildup of black powder residue in the barrel. It's going to help lubricate the bullet as it travels down the bore. I might have poured this wax sheet just a little bit on the thick side, but overall not bad. I think we're going to have just enough neck space to fit all this junk here. All right, seat it home. And I promise you there is no air in that case anywhere. And that's what we're looking to accomplish. So we're going to move on, get these prepped up, move back over to the press and start seating some bullets. Let's do it. All right, guys, we're near the end of our video here. We're going to finally start seating bullets and making a completed 577-450 Martini-Henry cartridge. So to recap, 24 gauge MagTech shot shell hole that's been trimmed to 2.9 inches. We've annealed it, run it through our die, did our final bump, made sure the shoulder was set back all the way. We primed them, went through and added 85 grains of black powder, which would replicate the original military loading. We added a tift of Polyfil to take up a little bit of extra airspace that we got because of how thinly drawn this brass is compared to the original cartridge. We added a 30 thousandths inch thick cardboard wax disc, which basically just a milk carton that's been sliced out. All right, a plug of wax, and then another carton piece, and then now we're going to seat our bullet. All right, so we flared it already. Drop the bullet in place and drive her up in the die. That's pretty much it. All right, and I've just got a little rag here to wipe off the excess wax that builds up that's left over from the lubricizer die. So there you've got a formed, ready to fire 577-450 Martini-Henry. A lot of work goes into making this ammo, but I tell you what, the benefit that you get from it, when you squeeze the trigger on the first one of these rounds that you made yourself, it's a very gratifying experience. There's a lot of cost, both in time and in effort to do something like this. It's a lot of effort to shoot this cartridge, but it's certainly worth the time. You know, if you're a military rifle enthusiast and you deal with this kind of stuff a lot, it's certainly worth your time to do it. All right, so that seated nice. Basically, when we seated this projectile, what it did was it pushed the whole arrangement, the cardboard disc, wax, and then the other cardboard disc, it pushed it down and just really squeezed that polyfill nice and tight against the black powder. We don't have any air in this cartridge. That's one of the main things with loading black powder cartridge guns that you want to be sure of, that you don't wind up with any air left in the case, because you can get some pressure spikes, which are certainly unsafe, you know, especially if they are excessive, okay? So guys, this came together quite nicely. This ammo is ready to shoot. So in case you guys haven't been able to figure out already, we do have some more Martini-Henry videos in the pipeline for you guys. We're going to do some long-range accuracy testing, some stuff like that. I hope you enjoyed today's video. Certainly a labor of love. If you really enjoy shooting military rifles, namely the Martini-Henry, if you're not willing to hand load, you're going to spend a metric ton of money to shoot this thing. These rounds, of course, you saw all the processes we had to go through to load this particular ammo, but these rounds are costing me around $1.40 a piece, and that's using premium Swiss black powder. So not so bad as long as you're willing to put a little bit of time and effort into it. It's very rewarding. There you go. We appreciate you watching the video, and go out and shoot your martini. Have a good one.